Hello everyone, welcome back to my YouTube channel. So in today's video we have this integral question. Okay, we have to integrate this with respect to x. Okay, so the first thing we are going to do is to make a substitution to get rid of this x over here. So we let ln of x equals a variable that is u. That is what we mostly use. Okay, so the u dx will be 1 on x. Okay, so that means dx, if you want me to make dx a subject here, it will be x du. Okay, so the reason why after making this substitution we differentiate is that we are introducing a new variable that is u. Okay, so we are no more integrating with respect to u, with respect to x, but with respect to u. Okay, so we differentiate it to get an expression for dx in terms of u, in terms of du. Okay, so making our substitution, ln of x is now u over x multiplying x du. Okay, so they will cancel out. Then we get this. Okay, so we are going to make another substitution. Okay, so we let w of u equals another variable, let's say a. Now if w of u is equal to a, then that means u is equal to a e power a. Okay, like if you have x e power x equals, let's say 2, you want to find this, you take the product log on both sides, then x will be equal to w of 2. Now if you want to get rid of this w, or you want to get this equation back, then you have to write x in terms of this. Okay, so that is the reason why if w of u is equal to a, then u is equal to a e power a. Alright, so from here we differentiate with respect to a. Now this is a product, so using the product rule, this will be the derivative of a, which is 1, multiplying e power a, plus the derivative of e power a, which is the same e power a multiplying a. So it's the same thing as e power a plus a e power a. Okay, that means du, that means making du the subject, du will be equal to e power a plus a e power a dA. Alright, so w of u is now a, then du is now e power a plus a e power a dA. So expanding this bracket, we get a e power a plus a square e power a dA. Alright, now we just have to work for the integral separately. After that we sum them up to get the final integral. So let's work for them separately. If we work for the integral of this, we are going to use the integration by parts. Then the formula is integral of u dv equals uv minus integral of v du. Okay, so that means we have to compare, u will be equal to a. U is mostly a single variable, so u is equal to a, then du dA will be equal to 1 definitely. So that means du is equal to dA. So it's just, we are comparing this to this. So if u is equal to a, then that means the whole of this will now be dv. So dv will be equal to e power a dA. Integrate both sides. This is with respect to v, so we get v equals, this will be equal to e power a. If you integrate e power a, it's the same thing. Okay, so that means integral of a e power a dA, going by this formula, will be u is what's a, and v is e power a minus, so that'll be e power a. Du is now what's dA from this side, so we get this. Okay, now if you integrate e power a, is the same thing as e power a. So this will be the integral for this one right here. Let's work for the other one, that is integral of a square e power a dA. So using the same integration by parts formula, a will be equal to a square will be equal to u, then du dA will be 2a, then du will be 2a dA. Alright, so that means the remaining part will be dv. dv is equal to e power a dA. Integrate both sides, we get v equals e power a. So that means integral of a square e power a dA, going by the formula, that is uv minus integral of v du. U, which is a squared, v is ea minus integral of e power a. In this case, du is now 2a dA. Okay, so we get a squared e power a minus, we can bring this 2 to the other side of the integral sign, So we get a e power a dA. Okay, so we've already worked for the integral of this. Okay, so we get a squared e power a minus the integral of this was a, so we have these two here, multiplying a e power a minus e power a. Okay, so we get a squared e power a minus 2a e power a plus 2 e power a. All right, so we've worked for the separate integral, so we just have to sum them up for the final integral. So that will be a e power a minus e power a plus a squared e power a minus 2a e power a plus 2 e power a. Definitely plus another constant c. We will introduce it in the final answer. So okay, so you get a e power a minus e power a. We are just adding them up. You have a squared e power a. You have this. Okay, so we have a e power a here, then another a e power a. We have a squared e power a as the only one. So we have this minus that will give us minus a e power a. We have minus e power a plus 2 e power a, so we get plus e power a. Now we can see that e power a is common in all of the three terms. So we get e power a out. We have a squared minus okay, there's no a here, so we get a squared minus a plus 1. All right, so we are done with the integration. We just have to reintroduce our substituted terms or expressions. So what was a? A was equal to w of u. So replacing a with w of u, we get this. So this is squared minus that plus 1. Okay, now e power w of u is the same thing as u over w of u. Okay, now the reason is this. Let's say e power w of u is equal to a. This is not really part of the solution. I'm just trying to prove why this is the same thing as that. So let's say we take natural log on both sides. We get w of u equals ln of a. Okay, so if w of u is equal to this, then that means u is equal to this multiplying e power ln of a. Okay, but this is the same thing as a, so we get a ln of a. We can divide both sides by ln of a, so that we get a equals u over ln of a. All right, now what was a? A was equal to e power w of u. Okay, so e power w of u equals a. So replacing a with e power w of u, get e power w of u equals u over ln of e power w of u. Now we can bring this to this side, so we get u over w of u. So we've proven that e power w of u is the same thing as u over w of u. So this is not really needed in the solution. I just wanted to prove it. Okay, so with that being said, we can rewrite this as u over w of u multiplying w of u squared minus w of u plus 1. Okay, now we can multiply through by 1 over w of u, so we get u over w of u squared over w of u minus w of u over w of u plus 1 over w of u. Okay, so simplifying it, this one will get rid of one of this, so we now have this minus, they will cancel out 1 plus 1 over w of u. Then our final substitution, what was u? From the start of the solution, we made u to be equal to ln of x, so replacing u with ln of x, we get this minus 1 plus 1 over w of ln of x plus constant c. Okay, so this will be our final answer. Alright, so this one right here will be our final answer. Alright, so yeah, this is it. Thank you for watching. Please do well to like and subscribe to my channel. I know people really watch my videos. I mean, not so much views, but not so many views, but please, if you do watch the video, please do well to subscribe so that I can make more videos comment also on videos you think I should make. Okay, so thank you for watching, and I'll see you in my next video. Goodbye.